if chemistry is the study of matter, do you even know what matter is? And so every book, science books, even in middle school, they try to teach you what matter is. Do you remember any definition in any grade about what matter is? What do you remember, Matt?
Like anything with mass is matter.
And you know what they do in elementary school? They say anything that has weight, and they say takes. Let's see.
Takes up space.
Is that what they say in elementary? Yeah. Then they get to middle school, and sometimes they start using mass instead of weight. And then instead of saying takes up space, they might use the word what?
Volume.
Okay. So really, almost anything you can think of is made of matter. So humans had to figure this out. They made some mistakes along the way. At one time, even chemistry books had a piece of matter called caloric. They thought caloric was something that would go into materials and come out, and it was later found to be heat. And at one time, they thought caloric was matter. But now we know that matter has to have mass, and it has to have volume. So almost everything you can think of. Now, some things that don't have mass and volume for a 10th grade chemistry class would be things like light or electricity or gravity or heat, okay? Those are things that are not really made of matter. Now, if you stay in science late enough and you get a high enough level, even that, later you might break down a little bit. Like, for example, here's this guy, this smart aleck guy, his name is Einstein, and he said this. And he said, you know the most ingenious thing here? This is energy, this is mass, and this is the speed of light squared. First of all, what in the world does the speed of light have to do with energy and mass? Well, he thought they're related. The speed of light, as of right now, doesn't change. It's a constant. I think that's kind of weird myself. The speed of light's a huge number. What if you square a huge number?
It's even bigger.
That's real big. So he said a little bit of matter, a little bit, times this huge number will give you how much energy? A lot. He said, and the most ingenious thing he said was right there, that equal sign. What? He said mass is energy. Energy is mass. Now, before Einstein, though, in the regular chemistry books, they don't do that. They say matter has to have mass and take up space. If you stay in science long enough, you can get into that. I'm not getting into that in this chapter. But, okay. So, anyway, we have these things called states of matter, right? States of matter. Let's flip this over. And what I'm going to do is, even in middle school, elementary school, they do solids, liquids, and gases, don't they? I'm going to do it a little bit differently than they do it. There's a chart up there. That's one of the things you're going to do in your homework. It says here, what's it say? I'm going to read here. Solids. It says are rigid. They have a fixed shape and volume. Liquids have a definite volume, takes the shape of the container. Gas has no fixed shape or volume, blah, 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 blah. Those are the kind of things that you kind of do in elementary and middle school. Now, what I did, what I did is, and I kind of scribbled these out, on one of the last packets I gave you, I made a chart like this. And so we're going to look at that for a minute. Okay, so now, if you're a solid, and we can take a solid like this. Here's a solid, and it has a shape, doesn't it? But watch it now. What happened to the shape? Did it change? Why not? No, I'm serious. Why not? Look. See this water? See what shape it's in right now? Oh, what are you doing?
It's a different shape.
Changing shape. What? Okay, so solids have a definite shape, don't they? What about its volume? What do you think? Is it changing volume?
No.
Okay, so it has a definite volume, doesn't it? See, in middle school, this is something that is going to be a chart, and you better put the right answer there. You miss it. You don't have to know what they're doing. You just have to put the chart, all right? But we need to know. I want to ask you this question in just a minute, but so solids have a definite shape. They have a definite volume. And what if I drew a picture? What if I drew a picture of a solid? How would you make a mental model of a solid? If you had to write little particles, what would you do? Would they be really close together, or medium, or really far apart? And now, for the first time, this is why these are yes. Why does a solid have a definite shape? The particles are so close to each other, they all attract each other within a certain location, and they all pull themselves and keep them in that shape. They keep them in that volume. This is why they have a definite shape and definite volume. Now, here's a question they almost never ask in middle school. Is a solid compressible? Can you squeeze it into a smaller space? And you have to be careful about that, because if I took a piece of clay and I found its volume, and then I took the clay and put it into a flat pancake, would it have the same mass?
Yes.
And yes, because I didn't take any clay away and I didn't add any clay, it has the same mass, right? Would it have the same volume?
No, because it doesn't occupy the same space.
So even though it's much smaller in height, it's much,
Wider.
so it actually has the same volume, doesn't it? So the same thing with a piece of steel. They have machines that can press on things, right? And they have machines that pull things apart until they break. They have other machines that push you. Anyway, essentially, you cannot compress a solid. So if I had a solid piece of steel and I squeezed it and I let it get flat, it still would have the same volume. Why? There's the answer right there, that picture right there. Let's jump all the way to gas. Do gases have a definite shape? Here's some right here, and ready? Oh, okay. What shape does it have? What if I had a balloon and I squeezed the balloon? It might get real long, right? What if I took all the air in this room and put it in a scuba tank? What shape would it have then?
Scuba tank.
The shape of the scuba tank. Why? Why are you allowed to take so many shapes? What allows you to have many shapes? By the way, what about your volume? If I took all this air in the whole room and put it in a small scuba tank, does it have the same volume? Let's see. Here's a volume, and here's a volume. Are they the same? No. This is small volume. That's huge volume, isn't it? If the gym was a great big vacuum, and I took a little balloon and pushed it in there and put all the air in there, the air in the balloon would fill the gym. It wouldn't be very dense, but it would fill this container. What is it that makes gases not have a definite shape, not have a definite volume? Yeah, go ahead.
Distance that the particles are away from each other.
The particles are where?
They're spread out. They're not.
They are. There's a huge amount of space between them.
I guess that's
Yeah.
true.
Now, you know what I used to think, though, when I was your age? Okay, they're spread out. Well, then what's in between them? And I used to say, must be air. Wait. Think about what I just said there. When I said, what's between the particles? If I have a balloon full of helium, what's in between the particles of helium? What's in between them? Nothing. What? Nothing. All right. I'll tell you what time is it? All right, we gotta go. Hey, I will be here today at lunch. I know I'm already helping one person, but if you need some help today, I'll be here after school. I'll be here tomorrow after school. I'll be here. All right. Thank you very much.